Hello everyone. Today we'll study the basic chemistry of aromaticity, some basic concept, and then we gradually we will go to the advanced level. So there are lots of video on aromaticity. You can go and check it out. But my main motto is that from basics to I will go to advanced level. So what is aromaticity? We know that the scientist Huckel discovered the aromaticity some rule. So what is the rule, Huckel rule, that we will learn gradually. So uh, according to Huckel's rule, that some of the conjugated and cyclic aromatic molecule like organic molecules, they are much more stable. Why? Because of this aromaticity term. So let's take any organic molecule first. Okay, benzene. This is the most simplified organic molecule. So how many pi electrons are there? 6 pi electrons are there. 6 pi electrons and 3 pi bonds. Don't miss it up. Okay. So now, according to Huckel's rule, it is saying that any molecule has to be aromatic when it is cyclic. Okay. Then planar and conjugated. Okay. So let's verify with the benzene. Benzene is a cyclic. It's a plane and it's a cyclic planar and also conjugation. And how conjugation is happening? We know the pi electrons can rotate and give the other resonating structure like this. That's why so many times we are giving this circle because of its conjugation. So like if we draw for better understanding the pi orbitals, okay. So these are the nodes, positive and negative we know. So here we can see that this pi orbitals are making a double bond. So to making a double bond, we know that all the time the pi orbitals should be in same plane. Like if we draw x, y, z. If we are talking about the xy plane pi orbital, this is xy plane. So there will be a bond. And if we are talking about yz, then you draw this one. And yz, how you will draw? Like this one. So another pi orbital should be this one. Okay. So it will rotate the conjugation. Like now it will be here, it will be here, it will be here. So this is. So now this is the basic. So let's forget about this. It is later we will discuss more. So benzene is cyclic planar conjugated and verify this 4n plus 2 pi electron rule where n is equal to 0 to n. Okay. So if n is equal to 1, where we can see it is giving 6 pi electrons. So benzene is aromatic and that's why it is a very stable organic molecule. Okay. So why the stability of benzene we know? One of the important reason is it's a aromatic. So for aromatic 4n plus 2 pi electrons, n is equal to 0 to whatever. So then what will be the value? 2. Then n is equal to 1, then it will be 6, n is equal to 2, 10. If we can see any molecule has these pi electrons, it will be a aromatic. So this is some basic concept for aromaticity. But Huckel is saying there is a opposite characteristics also, that is anti-aromatic. So what are the difference? First of all, for anti-aromatic molecule also it has to be cyclic, planar conjugated. But here, these are, I am making some important point. The planarity of anti-aromatic is not as good as aromatic. For benzene, it's like plain, but sometimes non-aromatic, it's not the exact plain. Some structure deviation will be there. Some basic example of cyclobutadiene, first of all. That we will discuss later about more on that. So cyclobutadiene, how many? 4 pi electrons. So according to the Hooke's rule, sorry, one more important, 4n pi, then it will be antimatic. So 4 pi electron for cyclobutadiene. So n is equal to 1, then 4 pi. So it's an anti-aromatic molecule. So now the important point, that anti-aromatic also giving stability, then aromatic is also giving stability, but there are opposite pi electrons. So what is the matter? For right now, you just keep in mind that aromatic stability is much more. So stability of aromatic, why it is that we will discuss on later. It's a little bit complicated. So stability of aromatic all the time. So now we understand that benzene is much more stable than cyclobutadiene. Some angle strain is there, structure deviation is there. So after that, like there is also like 4, then 8, then 12. So after 4, we can take 8. So we can take aniline moiety. So what is aniline? So 8 pi electron, 4n pi system fulfilling, it's a aniline. Okay. So it's a alto antiaromatic. But now the question about it is not as planar as this benzene. So in the video I will attach the 3-dimensional structure of both so that we will get to know. So now the point is that if anti-aromatic and aromatic, those are different terms, what will be the change of their properties? So first we will discuss the change of UV properties, then we will discuss the change of NMR properties and some DFT, density functional theory, some quantum calculation. These three also we will study on the next video. And one more final thing is that if any molecule is not satisfying any of these or these conditions, those are non-aromatic. Like if it is not cyclic, it's a non-aromatic. If it is not conjugated, it's non-aromatic. If it is like, no need to see any further things. So 3 types of systems are there: aromatic, non-aromatic, anti-aromatic. So in the next video, we will see the property change of that aromatic and anti-aromatic molecule.